Hello and welcome to the Energy Resilience Lab. Our lab is dedicated to giving you the knowledge, skills, and the encouragement that you need to become energy independent and energy resilient. So today we're jumping in on another product, just the next step in size. Drop-in replacement for a lead acid battery in a camper or overlander or even a small cabin, depending on your power requirements. Just to give you some history on this type of product and what the differences are between lead acid and lithium. At this size, so this is 105 amp hour, would weigh around 80 pounds. This product weighs 22 pounds approximately, one of the lightest on the market. There's a lot of different brands of lithium. They range usually from about 20 to 35 pounds for the 100 amp hour battery size. There are larger batteries that are being made now. So there are some that are around 300 amp hours. So you can look out for those if you're looking for a lot of energy storage. So that's kind of the weight of the battery. The charging capacity is another big differentiator. Lithium batteries can charge at a 1C rate, which is 1 times the capacity. So you can charge the battery in 1 hour essentially. It can be limited by the BMS, so some cells or BMSs won't allow you to charge faster. The preferred amount of charging is usually around a half C, maybe a little less, like 0.45 C on batteries like this, but you can charge it in an hour if you need to. The lead acid counterparts, if you have a lead acid system, even if you have enough power to charge it in 1 hour, the battery isn't able to accept that charge, and so you're limited by the charging rate of the battery. So you can charge to 80% maybe in 2 hours or so, but then if you want to take it all the way to full, you have to charge for, I believe the latest fast chargers with all the different stages can do it between 6 and 8 hours. And so you're looking at, so in this application, you're out camping in your RV, you're using your batteries. The lithium batteries are going to be able to discharge longer, so you can discharge these all the way down so you get the full 105 amp hours. Whereas with lead acid, the flooded lead acid, you usually don't want to use more than 50%. And with the AGM batteries that are sealed lead acid, usually you can take those deeper, so you can use about 80% of the battery capacity and still be good to go. So this is 100% AGMs, probably 75% capacity, and then the flooded lead acid would be about 50% of the capacity. So you're able to camp for about twice as long is usually what people estimate using the lithium batteries. The other benefit is you don't have to charge as long. So if you have a big enough charger, you can charge it in an hour. So if you're using a generator once every few days, then you can charge for maybe 2 hours or 3 hours once every few days, as opposed to with lead acid, you may have to charge every day and a half, but you have to charge for a long time. So you're charging for 2 hours for one battery. So if you have a couple hours, that's 4 hours. A couple batteries, I mean, that would be 4 hours. And then if you want to take it to full, then you're getting up there into the 6 to 8 hour time frame. So essentially your generator's running all the time when you have a lead acid battery system, which just shows you what lithium can do. So they're a lot more powerful. One of the other concerns that comes up, so one of the concerns with lithium is that you can't charge below 32 degrees. Some batteries allow you to at like 27 degrees Fahrenheit, but so in the colder climates, lead acid is able to charge through all those climates. Both types of battery are less powerful in the winter when it is cold. And so some of the things that you would want to do is you'd actually want to install these batteries inside your RV like storage bays. Whereas with lead acid, that's not allowed in most cases because they will off-gas, especially in the case of a flooded lead acid battery. So those are kind of the benefits and drawbacks of these systems. There are options for these systems to get a little battery heater. So you just have a little heater strip on the side and then a little thermostat, and the thermostat turns it off and on as needed, keep you at a temperature where the battery is going to perform very well. This battery and other batteries like it can do higher discharge as well. So there's a lot of cases when you're installing an inverter in an RV that your inverter is going to have a lot of capacitance. So when you hook up the battery to your inverter, it's going to draw a lot of current to fill the capacitors. And so some batteries like this one allow a lot of current at the start to just charge capacitors. Other ones don't, and so you'd have to use a resistor on the power source between the battery and the inverter every time you disconnect and reconnect it to limit the amount of amps going into the capacitor, so it's a slow charge. One of the drawbacks with that is that if you winterize your RV and you have a thermal disconnect between the battery and your inverter system, then that every time you shut that off, the capacitors will drain and you have to recharge it. So you're going to have to use a resistor again to bring the charge up on your inverter before you switch it over and direct the full power to the system. So those are kind of the system issues that can arise. Other benefits of lithium would be, so first of all, the lightness. Just having that much less weight is very helpful. These batteries can also go into marine environments where you are trolling. So if you have a trolling motor, usually the nice ones like Ulteras and others that are computer operated, they're usually 24 or 36 volts. And so with these batteries, they come designed so you can put these batteries in series. So you can stack 3 of these batteries in series to get 36 volts or 4 in series to get a 48 volt system. And then you can do stacks of these at the same number in series in parallel. So you can do 3 in series and then 2 or 3 in parallel. That'd be 36 volts at 315 amps if you had 3 in parallel. And you can just keep stacking the batteries to get to the size that you want. Commonly in an RV, kind of the basic system would be just to replace the lead acid batteries on the tongue of the tongue pole trailer with lithium. Usually in that situation, you're not using an inverter, you're just using these to power your 12 volt system in your RV. But you can make changes to it and add an inverter to your system. I'm going to be coming out with some training videos on how to build a basic RV system, so watch out for those in the future. And if you guys are interested, feel free to get those and follow through and build your system. But kind of the basic would be you have 2 batteries in the front, you're just connecting to the 12 volt system. The next system up would be you still have 2 batteries, but you'll usually put them inside the cargo section of your RV towards the front, towards the tongue of the trailer. And then you'll add just a small inverter there, and then that can be used to run CPAP machines if you're going to be off grid for a while, or you can run the extension cord from your RV around and plug it into your inverter in the front. When you do that, you have to disable the charger that is in your the standard charger that comes in, like wired in, hardwired into your RV. So they'll usually come in your little fuse box and breaker panel in your RV, and so you can just flip the breaker to shut off power to the charger that would be charging your lead acid battery that's in the front. The reason you have to do that is because if you're running an inverter off of your batteries around into your RV, that charger is activated, so it's trying to charge your battery that it's running off of. And so with the thermal losses of the inverter, you're just going to be losing power constantly because it's going to be trying to charge the battery with energy from the battery. And so the thermal losses are going to kill the battery. You're just going to lose 10% constantly, and it'll just drain the battery down to empty. And so you have to shut that charging system off. And then in that case, it's best to get a charger there that's dedicated, so you just plug in a charger at the front of your RV, and that's where you charge the system. So you just disable the charger that's built into your system, to your RV itself. And then the next step up from there would be to add a transfer switch in the back of the RV. So usually the wire that you'd plug into an RV park is at the back of the RV, And where it comes in, there will be a little junction box, and that's where it breaks out to go forward and everywhere in your RV. So it'll come up and hit your breaker panel, and then it'll spread out to the whole RV, powering all the different systems. In that case, you can build a system in that area and then just add a transfer switch. So a transfer switch just has 2 inputs and 1 output, and then it has just a small micro controller in there, or a small analog circuit that just times it, and so when you supply power to it, it will move the transfer switch and supply power to your rig, your RV. And then as soon as you let go, the transfer switch will drop and it will connect the inverter system to your whole RV. And then the charger for your system is installed on the back side of the transfer switch, so it only has power when you charge in from the outside of your RV. So when you plug it in, it starts charging. When you plug it into the grid or some form of grid, it could be a generator, it powers your whole system, as well as activating the charger to charge your battery system. So that's an automated way where you can just plug it in and it'll charge your batteries and it will power your rig when you're at an RV park. And then as soon as you disconnect it, if the inverter's in the on state, it would power your RV from the inverter. If your inverter's off, then nothing would be powered and it's just ready to go when you're ready to go. So you can just flip on the inverter and that will power your rig. So those are kind of the 3 levels for a tongue pull energy storage system. Once you get into motorhomes and big fifth wheels, you run into more issues because they usually have 50 amp split phase plug. So you're going to have 2 legs of 110 coming into the RV, and it is routed through, usually on a lot of those, the generator's already there. And so it'll have a transfer switch that will isolate the generator from the system, but it'll come through there and then it will go to your breaker system. And so if you want to intervene on that one, you can install an energy storage system in between the generator and the transfer switch. And what that does is it makes so the power from the grid leads, so it's the highest priority, it's the cheapest, less, you're using less fuel. So it will lead, so if you plug that in, it powers your whole system. If you unplug that, then it goes to your energy storage system with your lithium batteries and solar array or whatever you've got. And then behind that, the generator is connected to your inverter system, and the inverter can kick on the generator as needed to charge your system. So then you have a fully robust energy system where the grid leads, and then you'll go to your solar system, and then the generator's always there backing up. And that whole system can also be deployed in a home or in a business that needs 100% power uptime, because having redundant systems like that means that if any of them go down, you can still use the alternate or multiple of the alternates. So that gets you fully robust. So we'll be coming out with classes in the future. The classes are going to be for specific things. So the first one is just kind of a basic, how you would install solar energy storage system in an RV with an inverter without a transfer switch. So it's just basic, where you would use an extension cord to power the system, and you'd be isolating the charger that's built in and adding an additional charger to charge your system. But it'll be fully laid out with all the details and overcurrent protection to protect the wiring of your system if something were to go wrong. So it'll be an excellent training for you guys just to get started and start getting your hands dirty working on energy storage systems. Thank you guys for watching, and if you're interested in learning more about energy storage systems and how they're deployed at all different levels, from power banks all the way up to commercial utility, please like and subscribe and share this channel with anyone that you believe is interested. We are trying to get the word out and get people excited about taking control of their power in their home or in their RV to become resilient, so that you can control your situation and be able to handle problems that arise in the world, because there's a lot of power issues that come up, and the more you empower yourself, the better you are at bouncing back from problems. So thank you guys for watching, and we'll catch you guys next time. Have a great week. See ya.